Hey, welcome back everybody. So a former student of mine suggested this integral, and I thought it'd be a good time to solve it now. So we want to solve the integral of arc sine of x minus arc cosine of x over the arc sine of x plus the arc cosine of x dx. So the first thing we want to note is the following. So let's note, we just proved this. So let's note that the arc sine of x plus the arc cosine of x is equal to pi over 2. So that's the first thing we want to take care of. So the denominator is pi over 2. So this must be equal to the arc sine of x minus the arc cosine of x over pi over 2. But I can bring that out in front as 2 over pi. And so now, as it stands, this seems maybe a little bit too complicated. It might be a little bit easier if we were able to write these in terms of the same inverse trig function. And it doesn't matter which I choose, so maybe I'll try to write them both in terms of arc sine. So let's find some sort of replacement for this. Let's do a little bit of algebra on the side. So I'm going to say, let y equal the arc cosine of x. And, well, if x is in the domain of arc cosine, so if x is in the closed interval from -1 to 1, then I'm allowed to rewrite this. Just properties of inverse functions. So that means that the cosine of y is equal to x. But remember, we can rewrite the cosine of y, that's exactly the sine of pi over 2 minus y. It's a famous property. And that's equal to x. And then we can just take the arc or inverse sine of both sides. So if I take the arc sine of the left, that's going to cancel out that sine. That's going to leave me with pi over 2 minus y. And then if I take the arc sine of the right, I have the following. So this means I can algebraically solve for y. So maybe I'll just subtract that over here and just add that there. And so that means that pi over 2 minus the arc sine of x is exactly y. But what did we say y was? Y is arc cosine, and that's what we wanted to replace. So we can now replace that, and this is very nice. We have this in terms of the same trig function. So that's going to give me the following. So I've got 2 over pi times the integral of, looks like arc sine of x minus, now this quantity we said was pi over 2 minus the arc sine of x. And that's dx. Okay, so I've got some like terms here with the arc sines. So that gives me 2 over pi. I've got 2 arc sine of x minus pi over 2 dx. And so now I'm looking at both of these, and I know they're going to require different techniques to solve, so it might not be a bad idea to split this up into the difference of two integrals. Remember, the integral is additive, which means we can split it up over plus or minus. Okay, so let's do that now. Okay, so what does that give us? So I'm going to have 2 over pi times the integral of 2 arc sine of x dx minus 2 over pi times the integral of pi over 2. Now they're reciprocal, so that's very nice. Dx. And so here maybe I'll just factor the 2 out. And so that becomes 4 over pi. So it's arc sine of x dx minus the integral of 1 dx. So this is fine. This is not an issue. And this is actually a classic problem from Calculus 2, and we can solve this using integration by parts. Okay, so maybe I'll star this. Okay, so let's see here. So let's let u equal our inverse trig function. So that's going to be arcsine of x, and then dv will be everything else, so namely the dx. So I need a du, so the derivative of arcsine, that's 1 over the square root of 1 minus x squared dx. And taking antiderivatives here, I can see that v is equal to x. Okay, so now I need my integration by parts. I just need to fill that in and be careful. So 4 over pi, that's going to affect everything here. So this is going to get replaced with uv. So let's see here, uv. So uv minus the integral of v. So v du. So v du. And so this quantity is replacing, it looks like this right here. So I still have this, so don't forget about that. Okay, so uv minus the integral of v du. And to solve this, I'm going to go ahead and make a substitution. So let's go ahead and say, let w equal, how about the inside function here? How about 1 minus x squared? And so dw is negative 2x dx. And so that means that negative 1/2 dw is x dx, which is nice. That'll take care of this. Okay, so let's see what we have now. So we have, well, we still have 4 over pi times x times the arcsine of x. Right, that was from before. And then here I want to be careful because replacing this is exactly this quantity. So I'm going to have a plus 1/2. And so I'm going to have a dw. And then downstairs is going to be the square root of w. Okay, so that actually doesn't seem too bad. I need to remember that all of this is affected by 4 over pi. Okay, so that's much better than it was. I can bring this up and then start to think about using maybe the power rule. So that'll be w to the minus 1/2 power dw. And then we still have this from before, don't forget that. Okay, so this seems pretty promising. I'm happy with this. That's nice. Okay. Okay, so we have this quantity from before. And now here, I've got plus, so 1/2. And now I'm going to take the antiderivative. So I'm going to increase the power by 1, so that's w to the 1/2. And then dividing by 1/2 is the same as multiplying by 2 over 1. And then I also have this, so that'll be minus x and then some plus c. But this quantity is affected by that. So let's tidy this up and then back sub, and I think we'll have our result. So we got 4 over pi, we've got x, arcsine of x. So it looks like the 2's here are going to cancel. So that's going to give me the square root of w minus x plus c from before. And again, don't forget this, I almost forgot. I said don't forget. This is affecting both terms here. And so now we just need to remember what w was. So if we go back here, it looks like w was 1 minus x squared. So we're just going to back sub in for w, and we'll have our result. So this is equal to 4 over pi times x times the arcsine of x plus, and again, in for w goes 1 minus x squared, minus x plus c. Very cool problem, and big thank you.